Open your book to page 330. This lesson is on direction angles, direction cosines, and direction numbers. So you need to know what all this means. So let's say suppose you have a vector is equal to 4i plus 4j plus 2k. Okay. So in this vector, your direction numbers are 4, 4, and 2. Okay. So 4, 4, and 2, those are your direction numbers. So direction numbers are 4, 4, and 2. So those are your direction numbers. Now, direction cosine is that you have to use this divided by its length. Okay. So so this is for the I, j, and k, right? So cosine of alpha is going to be equal to 4 divided by square root of 4 squared plus the 4 squared plus the 2 squared. So cosine of alpha, so this is a direction cosine. So cosine alpha is for this, so equal to 4 over, so if you work it out, this would be 6. And so cosine alpha is equal to 2/3. So that's your cosine alpha. Okay, and then you're going to cosine beta. Okay, so cosine beta is going to be equal to this one. So again, this is alpha, beta, and gamma. Okay, so again, because they're the same number, you're going to get 2/3, right? Because they are the same. And then cosine gamma is going to be equal to 2, right? 2 over 6. Okay. So again, 4, 4, 2, so it's 4, 4, 2. And so cosine gamma equal to 1 over 3. So this is your direction cosine. So alpha is for the I, beta is for the j, gamma is for the k. So use the direction number divided by its length. Okay. Then after that, direction angle is you have to get the angle. So alpha, get your calculator. Okay. So 2 over 3 second cosine. So this is equal to 48.19 degrees. Okay. And since the beta is the same, so angle beta equal to 48.19 degrees. Okay. And gamma equal to 1 over 3 second cosine. So equal to 70.53 degrees. Okay. So again, direction numbers are those coefficients. So 4, 4, and 2, those are direction numbers. Direction cosine is your cosine alpha, cosine beta, cosine gamma. And the cosine would be the direction number divided by its length. Okay, so again, so this would be 4 over the length. This one 4 over the length, and 2 over the length. And direction angles would be just the angle itself. So make sure you know the difference between the direction cosine and direction angle. So this is the angle, and this is the cosine. Okay, so make sure you know the difference between the two. Now, there's another theorem you need to know. It's on page 331. On page 331, it says the sum of the square of the direction cosine and the line of the line is equal to 1. So in other words, cosine square alpha plus cosine square beta plus cosine square gamma equal to 1. So this is a theorem that you need to know. Okay, so now let's go over some examples. So let's go to example 7. Okay, example 7, it says a line passing through P1 at -4, 9, 5 and P2 at 2, 12, 3. And you're looking for the direction cosines. Okay, so first let's get a vector P1, P2. So this minus I give you 6i, this minus I give you 3j, this minus I give you minus 2k. So in this case, your direction number is 6, 3, negative 2. Okay. So let's go and do the cosine alpha. So cosine alpha would be equal to the direction number, which is 6, divided by the using the Pythagorean theorem, so 6 squared plus 3 squared plus negative 2 squared. So cosine alpha equal to 6 over square root of, you can use your calculator, work it out, equal to 49. So cosine alpha equal to 6 over 7. Okay. So again, they ask you for the direction cosine, and so that's it for alpha. And then for beta, cosine beta is going to be equal to the 3 divided by, well, the bottom is going to be the 49. So cosine beta equal to 3 over 7. Okay, and cosine gamma is going to be equal to negative 2 over 7. So once you find the length, you can just keep it the same. And again, make sure you follow instruction. It asks you to find the direction cosine. So this is a direction cosine. Now, if they ask you for the angle, then you have to go and use your calculator to calculate the angles. Okay, let's go to example 8. Example 8, you have the symmetric equation x minus 1 over 4 equal to y plus 3 over negative 3 equal to z minus 5 over negative 2. And you're looking for the direction cosines. So here are your direction numbers. Okay, so here's your direction numbers. So what you can do is, so cosine alpha is going to be equal to 4 over, right? So again, this is your direction number. That's what's going to be the key. Divided by the length. So it would be the 4 squared plus negative 3 squared plus negative 2 squared, right? So cosine alpha equal to 4 over, okay, you can get your calculator, work it out, equal to the square root of 29. Okay. Now in this section, okay, you can just leave the square root on the denominator. Normally you don't do that. Okay. Now cosine beta equal to, it's going to be negative 3 over square root of 29. Okay. So once you find the length, you can just go and use that. And cosine of gamma equal to negative 2 over square root of 29. Now, notice in the book that what I did is, in the book, they can multiply the direction number by negative 1. So make because it's a line, right? So you can go in this way, or you can go this way. So another option is your direction number of is 4, negative 3, negative 2, right? These are too many negatives. So you can multiply this by negative 1, so it becomes negative 4, 3, and 2. So you can do that, multiply by negative 1. So instead of going this direction, you can go the opposite direction. Okay? So you can go either direction, and the difference between it is that they are negative of each other. So if you do it this way, your cosine alpha equal to negative 4 over square root of 29, and your cosine of beta equal to 3 over square root of 29. And cosine of gamma equal to 2 over square root of 29. Okay? So you can do it this way too, so it's perfectly fine. So, but the key is make sure you know how to get the cosine, direction cosine. Okay? Again, you just use the direction number divided by its length for each one. And this is for the I and the j and the k.